started, any questions on the homework? No? No questions on anything so far? All right. So we're finishing up the notes, or we're continuing on with the notes from yesterday. Probably not going to finish them today. We'll finish them tomorrow. So it's not that there's a lot to it, but I want to make sure we understand what we are doing. Because addition subtraction is, with fractions, is one of the few times that addition subtraction involves actually more steps than multiplication division. Because normally our division process, or dividing two things, takes a lot more steps than addition subtraction. Because when we talked about polynomials, we just combined like terms for addition or subtraction. Where dividing, we had to either use synthetic division or long division. There was more to it. Here, 741. So today we're finishing up the notes, and then we'll finish the note sheet tomorrow. So Friday. Right there. Yeah. Yeah. I don't need that piece of paper if you want to write it on it. So, I believe this is where we stopped yesterday, yes? Okay. So, welcome. Have a good one. We finished this one, yes? Or did we? Okay, we didn't do this one yet. All right, guys. So, what we're wanting to do with this here is this is going to be the start for our adding, subtracting rational expressions. Because again, we're looking at what's going to make them be the same. What is the first expression that we can turn both of these into? Now, to find it, the first thing we're going to do is factor these completely. We want to factor them down as far as they'll possibly go. And the first thing we should always be looking for is the greatest common factor. Is there a number or term that will go into 4x squared and 16? 4. So we'll factor the 4 out. And when we factor the 4 out of 4x squared, we have x squared. When we factor the 4 out of 16, we get 4. Now, x squared minus 4 is one of the ones we like factoring. Mainly because x squared minus 4 is a difference of perfect squares. Because they are being subtracted, x squared is a perfect square, it's x and x. And 4 is 2 and 2. And the signs would be opposite. Because a squared minus b squared is our a plus b times a minus b. And that's as simplified as it gets. Questions on the first one? Now we'll look at factoring the second one, our 6x squared minus 24x plus 24. Here, there's a greatest common factor of 6. So we can take 6 out of all three terms. When we take 6 out of 6x squared, we're left with x squared. When I factor the 6 out of 24x, we have minus 4x. Plus, when we factor the 6 out of 24, we have 4. Now, the feeling we went over factoring with you, yes? Or the cross method? Yeah, doing it this way. and then going through and filling in and finding the factors that way. Kind of, or dealing with the factors of the first and third, and we can fill in the x according to the numbers kind of deal, I think, kind of what they did. Yeah. Okay. I don't have anything against that method. So there's a way that I do it, and if you like that way better, stick with it. If you like the way I do it better, do that. Because again, my main thing is if there's a way that you like and it works every time, do it. It doesn't have to be the way I do it. So when I look at factoring, the first thing I look for is greatest common factor. The next thing I look for is signs. There's a third term. Sign is either going to be positive or negative. If it's positive, the signs are going to be the same, and they're going to match that middle term every single time. So I don't even look at any of the factors first. Since the third term is positive, signs are the same, match the sign in the middle term. Negative and negative. Now, after I get signs and all that done, I'm going to look at the factors of the first and third term. So the first term is x squared. The only things that multiply together to give me x squared are what? X and x. Only set of terms, so we're just going to throw it in. Factors of 4. 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. 2 and 2. All right, guys, focus in, focus in. Last thing we do is check. Last thing I do is check and make sure it works, and that's your old school did that, yes? And I have a feeling they started off with x times x, which is x squared. I don't feel that's necessary. And I have a reason for it. And they may have brought this up too. Where did we get these first two terms from? Factors of the first term, yes? So they should multiply together to get us back to the x squared. There's no reason to check it if that's where it's coming from. Does that make sense? Other one I don't check. This one here, 2 and 2. Well, where did we get 2 and 2 from? Factors of 4. So it's going to multiply together to give us 4. But the only way those won't multiply back is if, well, I decided to pick 1 and 5 for the factors of 4. So there's not a whole lot of reason to check those. The main one that changes depending on the setup is the middle term. That's the one that changes. And if it's the only one changing, yeah, that's the one I always check for because that's the only one that's going to change. No reason to multiply the rest of it out. X times negative 2 is negative 2x. Negative 2 times x, negative 2x, and our negative 2x minus 2x is indeed the middle term. Does that kind of make sense? I like it because it's a little more streamlined, and it works well. If you like it this way, that's fine. If you want to stick with the x method, do it. It wouldn't have worked with 1 and 4, because if we did have 1 and 4, let's try it. Because our x times x will be x squared. Our 1 times still negative 1 times negative 4 is still positive 4. X times negative 4 is negative 4x. Negative 1 times x is negative x, giving us negative 5x. Yes? So it's not the right middle term. So again, the main thing that changes, depending on the setup, as long as we have the correct first and factors of the first and third term, is that middle term. There's not a whole lot of reason to check first and third. It's just checking that middle. Does that kind of make sense? Yeah. All right. Least common multiple. Now that we have them factored, we're going to find the least common multiple. So we can start with, well, let's start with 4 and 6. 4 and 6 is kind of nice. They're both small numbers, so we can do the skip counting method or the factors. If we did skip counting, well, factors of 4 are 4, 8, 12, 16, 20. Factors of 6 are 6, 12. Least common multiple between 6 and 12, or 4 and 6 is 12. Because least common multiple gets a little more tricky when we start having more than 2, so 3 or more, or they get to be bigger numbers. Okay. We ready for the sets of parentheses? These factors here. Okay. We ready for this? All right, let's look at x plus 2 first. So our first equation has how many factors of x plus 2? 1. It shows up once, yes? How many does the other one have? 0. So x plus 2 needs to show up in our least common multiple how many times? Once. It showed up once in one of them, so we need it once. Okay. You ready for the other factor? So with the one on the left, we have x minus 2. In this one here, it shows up once. In our other one, it shows up twice. So how many times do we need the x minus 2? Twice. Since it showed up twice in one of them, we need it twice. It doesn't matter that it showed up once in the other. We need the most out of the two. And since it showed up twice in one of them, we need it twice. Even though it does total across the two, it shows up 3 times. That's not the important thing. It's the fact that it showed up in one of them twice. We need it twice. Because again, the goal is to get them to be the same, yes? So if I want to get them to be the same, for the one on the right here, to get 6 into 12, I just need to multiply the 6 by 2. The 2 times 6 gives us 12. Okay? It has both the x minus 2s, it's just missing the x plus 2. So if I multiply it by our 2 times x plus 2, we now get to that least common multiple. The one on the left, well, to get 4 into 2, we're going to have to multiply it by 3. It has the x plus 2, it has an x minus 2, it's just missing the second x minus 2. So if we multiply it by 3 times x minus 2, those two are now going to be the same. And that's it. Questions on this here? Because again, the whole goal is to get these two to be the same. And when we start looking at the least common denominator, same thing as least common multiple, except that the terms that we're looking at to be the same are going to be in the denominators, the bottoms of the fractions. Least common multiple, least common denominator. At their core, essentially the same thing. Least common denominator, what do we need to get the two denominators to be so that we can make them be the same? Least common multiple, the expressions. Only main difference. Questions on this so far? You all notice this here? Again, factoring, factoring, factoring. Least common multiple is 6x squared minus 54 and 9x squared minus 54x plus 81. Six x squared minus 54. Is there a greatest common factor between 6x squared and 54? Oh. Yes, sir. So 6x squared and 54 have a greatest common factor of 6. So if we factor the 6 out of 6x squared, we're left with x squared. We factor the 6 out of 54, we get 9. X squared minus 9 is a nice one. Since we have two things being subtracted, x squared is a perfect square. It's x and x. 9 would be 3 and 3. So it is a difference of perfect squares, which is our x plus 3 and x minus 3. I'm assuming you went over difference of perfect squares. Okay. Just making sure. Because the last thing I want is you to jump in and then it's all brand new. So that's not bad. 6 times x plus 3 times x minus 3. Let's look at the other one. 9x squared minus 54x plus 81. Has the greatest common factor of, well, 9. And if we factor the 9 out of 9x squared, we have x squared. Minus 9 out of 54x is 6x, and 9 factored out of 81 is 9. So we're factoring x squared minus 6x plus 9. Since we factored out the greatest common factor, we'll do 2 sets of parentheses with 3 spaces. And when we first went over this, I told them the exact reason I do 3 spaces is to make sure the parentheses are wide enough. That they serve no other purpose than that. Since our third term is positive, the signs are the same, match the sign of the middle term. So negative and negative. Factors of x squared are x and x. Now our factors of 9 are 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. And if we do check this here, we will get a middle term of negative 6x. Least common multiple. So we'll work with the numbers outside the parentheses first. So we have 9 and 6. Well, 9 and 6 are kind of nice, because factors in 9 are 9, 18, 27, 36, 6, 12, 18, 24, 30, 36. 18 would be the least common multiple of 9 and 6. 36 is a common multiple. And the issue with using 36 over 18 is that it's going to have an extra factor of 2. Because going from 18 to 36 is timesing by 2. And you're guaranteeing that when we add or subtract them, that extra factor of 2 is going to come out with anything else. So any factors that we put above the least common multiple, we'll have to factor it out later. So now for most part, if it's just a number, that's not going to be an issue. Factoring out 2 or simplifying the 2 out is going to be fine. But we're having to simplify out extra of our x plus 3, x minus 3s. It's going to make it a little bit harder. Because instead of having the degree of the top be, say, an x to the x squared, is going to take it from an x squared to x cubed, or x cubed instead of x squared. It's now, we added 2 of them. Now it's x to the 5th or x to the 6th. We're making it harder whenever we add an extra set of parentheses. Numbers, it doesn't hurt us too much. Variables, it starts making things harder than they need to be. Now, let's look at our parentheses. We can start with x plus 3. Well, the one on the left has one of them. The one on the right doesn't have any, so we need at least 1. All right, guys. Let's save it for later. The one on the left has 1x minus 3. The one on the right has 2. So we'll need it twice. So 18 times x plus 3 times x minus 3 times x minus 3 is the least common multiple. So, questions on how we got the 18? So 18, so 6 and 9, the first number that we can turn both 6 and 9 into, because 9, 18 is 18, 6, 12, 18. That's the first number we can turn them both into. All right? Now x plus 3. The one on the left has how many of them? The one on the right has how many of those? So out of both, the most that it shows up in either one is, so in the least common multiple, we need it. Let's look at x minus 3. Here it shows up. So what is the most times it shows up in either one? So we need it. If it showed up, so if it showed up here again, because it, again, showed up twice in both, so we need it twice. So if it showed up in one of them 3 times, then we need it 3 times. Yep. Which, however many it shows up in one of them the most, is the number that we need. Questions on this here? There's, I don't want to say simple. I don't like simple or easy. But there's not a whole lot to this concept. But there is a lot to this concept all at the same time. So we're going to look at another one of these here. We're going to look at one more of these here, and then we're actually going to start adding and subtracting. So we want to find the least common multiple of 5x cubed and 10x squared minus 15x. 5x cubed is nice to factor because it's 5x cubed. Single term, we can't do anything with it. It is as simplified as it gets. 5x squared minus 15x, or not 5, 10x squared minus 15x is the greatest common factor of 5. It's also what? X.
Caleb Butler, come to the office. Caleb, come to the office.
And if we factor that 5x out, we're left with 2x minus 3. So let's look at the terms outside. So we have our 5x cubed and 5x that we're trying to get to be the same first. So here, how many 5s do we have? Here, how many 5s do we have? So 5 is going to show up once. And they're already the same, so we don't have to do a whole lot with 5. Now we do have an x cubed here. So that means x is there how many times? 3. Here, x shows up. So how many x's do we need? 3. So it's going to be 5x cubed. Questions on how we got our first term? So the one on the left, the 5x cubed, we've got everything matched up with it. The only thing missing is our set of parentheses here. And since it shows up once, we do need it one time. It actually works out that the least common multiple is 5x cubed times 2x minus 3. And that's it. All right, now we're actually going to do some adding. Actually going to start adding these rational expressions. Yeah. Huh?
Well, you're the third person to go out. Take it down. We don't want to hear your food stories, Jonathan. It's great story.
All right, guys. So before we can start adding these two together, we need the denominators to be the same. Now, to be able to actually figure out what's going to make the denominators be the same, or the first expression that's going to make them be the same, we're going to need to factor them. Now, the numerators, even if they are factorable, we're going to leave them alone. Because when we add or subtract, we're going to have to add or subtract the numerator. So if there's terms in common, we're going to have to add them together. And if we factored it, well, we're going to have to unfactor it to be able to add or subtract. So there's not a whole lot of reason to factor it to immediately unfactor it. So we're going to leave it there. Now, out of these two denominators, one of them is a little bit nicer to factor than the other. And that's the 9x squared. Because that's it. I mean, we can't factor it any further than just 9x squared. Now, the other one, our 3x squared plus 3x, has a greatest common factor of 3x. And we can factor it out of those two terms, giving us 3x times x plus 1. Now, our least common denominator, because again, we're trying to get these to be the same, is we're trying to make 9x squared. Let's find out what's going to make 9x squared and 3x times x plus 1 be the same. We want the first expression that's going to make these two be the same. Now, just like what we've been doing, we can start off with our 9 and 3. I have a feeling you already know, but I'm going to ask anyways. What's the first number I can make both 9 and 3 be the same? 9. It's 3, 6, 9. So our first part of the least common denominator is going to be 9.
How are you back?
X squared and x. So in one of them we have 2, the other we have 1. So we will need an x squared. So that does take care of our terms outside the parentheses. The only factor we have left is what? X plus 1. So the least common denominator is going to be x squared times x plus 1, our least common multiple for the bottoms of these fractions. So if we're going to be able to add or subtract them, we need both denominators to be 9x squared times x plus 1. Because if I can get both of those to be 9x squared times x plus 1, we'll be able to add them together. Questions so far? What's not making sense? Okay. So we're trying to get them to be the same. So the first number that's going to make 9 and 3 be the same, 9. X squared and x, since I have 2 x's on the left, that means we're going to need 2 on both. So that's where we get the 9x squared. And since x plus 1 showed up in 1, we're going to need it in both. So the least common denominator, least common multiple, so this is going to be 9x squared times x plus 1. So that's what the two denominators are going to need to be so we can add. Yes? Now let's look at the one on the left. So we do have the 9x squared part of our least common denominator. What is it missing? The x plus 1, yes? I'm definitely going to have to multiply the bottom of this fraction by x plus 1. but I can't just multiply the bottom of it with it. I also have to multiply the top. Now, this does seem like an odd step that we can just multiply the top and bottom of this fraction by x plus 1 over x plus 1. But what is anything divided by itself? 1. So really, what are we multiplying this by? 1. It's just a very fancy version of 1. That's why this works, because if we multiply a number by 1, it doesn't change. We're not changing this fraction, we're just changing how it looks. It's still the same fraction, it's just going to look a little different. All right, guys, focus in. Because on top, we can go on and multiply this through. Because we could put 7 parentheses x plus 1, but I feel like at this point we can actually do that multiplication. We don't necessarily have to rewrite it. If we did have multiple parentheses, I would write those out before we start multiplying so we don't lose any terms. But here, 7 times x is 7x. 7 times 1 is plus 7. So on bottom, we'd have 9x squared times x plus 1. And on top, we'd have 7x plus 7. Let's look at the other parentheses, or other fraction. We do already have the x plus 1. But here we have x instead of. So that means I need another factor of x, because our x times x will give us x squared. Now we need to figure out what I need to multiply by 3 to get 9. 3. So on bottom, our 3x times 3x will indeed give us 9x squared. On top, 3x times x is 3x squared. Now we can actually add the numerators. Normally we would add them, put parentheses around them. Now with addition, that's not a big issue because we're not worried about or have a sign change that's going to occur, because that happens with subtraction. When we subtract, we have to distribute that negative through. So really at this point, if we wanted to, we could drop the parentheses and combine like terms. Well, three x squared, 7x, and 7, there's no like terms. We get this here. Now, the only thing left to make sure is that there's nothing in common on top and bottom. Because if there's anything in common, we need to simplify it out. So if there's going to be something in common on top and bottom, it's either going to match up with the 9x squared. There's going to be some greatest common factor between 3x squared, 7x, and 7. Well, there's not a greatest common factor between those. So the other chance is that it factors out and we have a factor of x plus 1. Does that make sense? Now, as it looks with this here, the likelihood that this factor doesn't seem too likely, because since the third term's positive, signs are the same, they're going to match that in the middle term. So we're going to be combining like terms. So if y'all remember last semester, I did give you a method for checking to see if something is factorable. And it's our square root of b squared minus 4ac. This here. Now, I don't know if they covered that. It's an odd thing, because I figured this out, or came across this, because this I've actually seen before. You know what? I'll get a chance to use the magic pen, because this isn't the full thing. The quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So the quadratic formula, so it gives us all solutions. It gives us every possible solution we can have. Now, if this is factorable, it means the number that comes out of this radical is not going to be negative. It can't have I, because if it has I, it's our imaginary solutions. This won't factor. If this gives me a radical, it means my solutions for this are irrational, which means it doesn't factor. So really, if for this here, the square root of 7 squared minus 4 times 3 times 7 gives me a nice number, a non-decimal number that doesn't have I, that factors. If it doesn't, that thing doesn't factor. So it's a nice way to be able to check and see, does this factor or doesn't it? And at this point, we can grab the calculator, say second square root, 7 squared minus 4 times 3 times 7, domain error.
It's off touching me.
Negative 35. So what that tells us is that we have the square root of negative 35 or I square root of 35. So it's imaginary and irrational. So that means the solutions are imaginary and irrational, which means it doesn't factor. Sometimes. Questions on this here? Questions on any of this so far?